Hello everyone, in this simulation we're going to investigate the relation between load and extension on the graph. But before, let's recall the definitions for load and extension. Let's click on definitions. The load is a tensile force causing an object to increase in length, measured in newtons. Recall that there's two types of forces: tensile force, which causes the stretching, and the compression force, which causes a decrease in length. So the load usually is a tensile force, which extends the length of the specimen. Let's recall the definition of extension. Extension is the increase in length of an object caused by a load, measured in meters, millimeters, or any unit of length. Recall that to convert from millimeters to meters, we divide by 1,000. So if this is the reference specimen and has an original length at this dotted line, after applying a load, the specimen will stretch and this will increase its length. The difference between the original length and the final length after applying the load is called extension. Now let's return to the virtual lab and click on Graph, and we're going to use the load slider to stretch the specimens and watch the graph develops. So we will increase the load. Notice how the graph is developing. What shape is the load extension graph? Well, it is a straight line. And what does this tell you about the relationship between the load and the extension? The extension is proportional to the load. And what law does this demonstrate? Yes, it's Hooke's law.